It all started back in 2003.
Kyle! What's up, Amy?
Hey, Amy.
Kyle, you brought Eric?
Yeah, I invited him yesterday.
Oh, okay.
You ready to get pitted?
Yeah, dude.
Let's go.
Yeah.
Oh my god, Amy, are you okay?
It's fine, Eric. Eric, I got it. You can go pay or something. I got it.
Okay. Why did I have to slam Amy's head in the door? You're so stupid, Eric. Ugh. I wonder what the parabola is of me making it in. To figure out how high I need to get the coin to make it in, I can just find the maximum of this parabola. To do that, I'll just find the critical numbers by setting the derivative of the function equal to 0.
Wait, Kyle, you said let go of it?
Wait, hold on, no! Oh! Kyle, oh my god, Kyle. Kyle, do you need mouth to mouth?
No! Go get a lifeguard or something!
Ma'am, my friend over there, he needs help.
What does my acceleration have to be in order for me to save the boy that got hit by the bungee cord? According to the law of motion, this is currently my movement. In order to find my acceleration, we need to first find the first derivative. In order to find my acceleration, we need to first find my instantaneous velocity, which is the first derivative, using the power rule, which is nx to the n minus 1 power. So, in order to apply the power rule to the first equation, we're going to take the 2 and multiply it to the 4, which gives us 8, and then 2 minus 1 is 1, so it's just 8t, minus, this has the first power, so we're going to multiply it to the negative 16, so it's negative 16, and since it's 1 minus 1, the t is no longer there. Since 15 does not have a variable, its derivative is 0, and this is the first derivative.
We're gonna need stitches. Stop! You! Call 911.
Before we take Kyle to the hospital, let's talk about velocity. So, if this is the equation for when the bungee cord hit Kyle, then what's the particle's velocity at t equals 2?
Go.
Okay, so first we start out by looking at the equation, and it's xt equals t to the 3 minus 4t squared plus 3t minus 2. So the first step is that you take the derivative of v to the t. Then we can pause.
Go.
So after taking the derivative, you get 3t squared minus 8t plus 3. Then to get the velocity, you plug in the t equals 2. So after plugging in t equals 2, you get negative 1 meters per second. And you're probably thinking, why is it negative 1? So it's negative 1 because the bungee cord's moving to the left on the x-axis or on the top of the car.
Yo, Eric's making a move. What is the maximum height of Eric's arm as it goes around Amy's shoulder? The equation for the height of Eric's arm as he puts it around Amy's shoulder is f of x equals x to the third minus 6x squared. Then, in order to find the critical points where you would find the maximum, you do the derivative of this equation, which equals 3x squared minus 12x. Then you would set this equal to 0 in order to find the critical points. Now you factor and find that 3x times x minus 4 equals 0. And then you find that x equals 0 and 4. So we can conclude that Eric's arm reaches a maximum at 4 inches above his shoulder while he is putting it around Amy.